You are welcome to physics class. Let's consider this question. A. What is meant by dimensions of a physical quantity? The answer to that question is dimensions of a physical quantity is the powers to which the fundamental quantities of mass, length, and time are raised. The second question, B, says the speed c of longitudinal waves in a stretch wire is given by the equation c equals the square root of E over rho, where E is the Young's modulus for the material of wire and rho is its density. Show that the equation is dimensionally correct. So let's write out the equation. The equation is c equals to the square root of E over rho. Now for this equation to be dimensionally correct, it means the dimensions of each term of the equation must be the same. So let's look at the dimension of c. The dimensions of c is, since c is speed of light, it has dimension of Lt raised to the power of -1. So we already know the dimensions of c. So let's look at the dimensions of the root of E over rho. So the dimensions of the root of E over rho will give us the dimensions of E, which is Young's modulus. Young's modulus has the same dimension as stress, and stress is force over area, and force is mLt minus 2 all over area, which is L square, divided by the dimensions of rho, which is density, mass over volume, which is m divided by L raised to power 3. If we simplify this further, we should have this square here can be written as L raised to power 1 and L raised to power -2 and T raised to power -2. That is for the numerator here. Everything here is the same thing as what I've just written down here. Divided by m L raised to power -3. And this is going to give us 1 minus 2 is -1. So we have m L -1 and T -2, all divided by m L -3 raised to power -3. So m cancels m. So we have here the root of the L power 3 goes up to become, we have L raised to power -1 and L raised to power 3, and T raised to power -2. So -1 plus 3, that will give us +2. So we have L raised to power 2 and T power -2. So the square root can be written as, we have Lt minus 2 can be written as 1 all over 2. So the 2 here cancels the 2 here 1, and the 2 here also cancels this -2 to be -1. So we are left with L1 and T -1. So you will see that from here the dimensions of C, which is Lt -1, is the same as that of the right hand side, which is Lt -1. So since the left hand side, the dimension of the left hand side equals to the dimension of the right hand side, we can say that the equation is dimensionally correct. Have a wonderful day. Bye bye.